Hello everyone, welcome to day 20 of competitive programming. Today we'll be solving yesterday's question which we have stopped from greedy algorithms. So let's open CodeChef now. It was row and column operations, right? We actually finished the half of the question. So please watch the previous video, that is day 19. And here it's second, it's 2 star. This is Pauli relation. Actually we solve this, and max, it's not that question. Okay. Let's change to CP. Yeah, it was a row and column, right? So this is it, row call. Yeah, here it is. Actually we also solve max also. Yeah, in all this 20 in these 19 days we have solved these questions. Actually interesting XORG. Okay, this is the question we are aiming to solve, and we'll also solve this question for today. So we actually solved it to complete operations. We need to search for the maximum number after the operations, but we were getting a runtime error. First let's compile it and then we'll run it. Okay. We'll take all these options and we'll paste it here. The answer is 7. Yeah, we got the correct answer. But when we are running this, actually we are getting runtime error. I mean when we are submitting it. See, like we'll try to submit it. We got runtime error. So there is some problem here. So I'm thinking, what could be the problem here? Why am I getting runtime error? K here is actually the value, it's not the index, it's like position. That's the reason we are doing K minus 1. Q, this while loop runs for every operation, 4 operations. So for 4th operation it will run for once, next third, next second, next first. So in that way it will be running for 4 operations. Why are we getting an runtime error? There is only one array to be maintained. Are we trying to access any values that cannot be accessed, like anything that is garbage value? We are not actually. So we'll change our approach actually. Since we are getting a runtime error, we'll try to do it more efficiently. So instead of maintaining an array, a 2D array, let's maintain two different arrays, one for row and one for column. Now after maintaining two different arrays, we'll initialize them to 0. All the values in the two arrays is 0, and that's it. We are reading the string, we are reading the k and v values. After reading the k and v values, if the string is having r in the starting, then we'll do row increment. Instead of doing this, we'll just say for that element in the row, for if that element is row is k, right? And so for the row k, just add the value. That's it. We'll add the previous value and the current value, and same we'll be doing for the column also. Column also will be doing the same. We'll be doing the same for the column also. Now after, I guess that's it. Now we got our row operations and column operations. After getting the row and column operations, what can we do? We'll take the maximum row operation and the maximum column operation, and we'll add both of them. Then we'll be getting our answer. That's it, right? So okay, we only need one for loop. Okay, let's say this is maximum of row and this is maximum of column. So m of row is equals to maximum of row of I comma m of row. Same with the column. Then instead of printing max, we'll add them, because row and column operations will be added to the one number, right? That's it, I guess. Let's compile it. Now let's pass our test cases. Yeah, we got 7. Okay, Now let's paste this here. Let's submit it. Hope we won't get a runtime error or a TLE, time limit exceeded. Currently running test case 3. Yeah, currently running test case 5. Yeah, we got the correct answer. Wonderful, wonderful. Yeah, now we have solved this question. We also solved max of mix and polygon relationship. So we will be solving interesting XOR. So let's clear this. Let's create a file irst XOR.cpp and let's close this file. Okay, you are given an integer c. Let d be the smallest integer such that 2 to the power of d is strictly greater than c. Consider all pairs of non-negative integers a b such that a comma b should be less than 2 to the power of d and a XOR of b is equal to c. Here that operation is a bitwise XOR operation. Find the maximum value of a dot b over all these pairs. Okay, the first line of the input contains a single integer t denoting the number of test cases, and the first and only line of each test case contains a single integer c. Okay, c strictly greater than c. Okay, we need to find the d value, right? Or it's not necessary to find the d value. The first time I read the question, it was like it's pretty straightforward. Now it feels like a little tricky actually. Okay, rough test cases for each test script in the single line, the maximum possible product. Okay, this is product a into b, and that's it, right? So here the binary representation of 13 is 1101. We can use a equal to 10 in binary and 7 in binary. This gives us the product 70. No other valid pair can give us a larger product. Okay, they are just finding the product here. The binary representation of 10 is and given as the maximum product as 91. So it's just numbers, right? So let's take an array snippet and we'll remove the array part from here. After removing it, now we will actually now we will be reading the n value. I got lost actually, sorry. So after reading the value n value, we'll be getting 13 as the input, right? Now after getting 13 as the input, what we need to do, I guess we need to calculate 2 power d. We need to calculate 2 power d. Or else can we do this without calculating 2 power d also? My thinking is we need to calculate 2 power d, which is quickly greater than c. Then we need to find a and b pairs. Like we know that if 2 power d is equals to x, okay, they will be giving us c will be given as the integer. Since 2 power d is c, then we can find d using the logarithm. Log 2 of c will be d, right? After getting that, how we'll be solving this? Should we perform the XOR operation, or it is not required to perform it? Well, I'm thinking is, let's read the c value. I mean, here it is n, right? After reading the n value, we'll just find we'll maintain a counter, and we'll take the value of yes. I think that process will not help us. How many more minutes we are having? 42 minutes we are having. What are the constants they gave us? C is 10 power 9 and T is 10 power 5 maximum value. I mean, one way is you can write all the powers of 2 until 10 power 9, I guess. Then you can take a for loop and compare when the C value will be lesser than those values, and then if it is less than, then we'll say d is equals to that value. We got the d in that way. After getting the d, we'll take the maximum of d and ci by applying the XOR operation between them. No, you cannot. Why need to operate d and c? It's not d and c. We need to find a and b, right? Okay, we'll do it this in this way. At least we'll write some code instead of thinking in a. So after reading the n, here if n is greater than 0, we'll take a variable. Let's take a variable p, which is the remainder of See, actually, see here it is an, after getting the reminder, if we are only having the reminder 1, that means it is not in the powers of 2, right? If we get 0, it is in the powers of 2. So let's first write the else part. If it is in the powers of 2, let's take a variable, say x, and we also need to calculate a and b, right? So let's also take a and b values, and every time n is greater than 0, we'll make it a half for every loop, n equal to and y equal to 2. So every time the loop runs, we'll be making it half, and also we'll increase our x value twice, so to find the correct power. So if it is an even number, then we'll increase our a and b values by x. Okay, then if it is not an even number, then we'll check whether if we divide the number by half, will that be equal to greater than 0? If it is greater, then we'll increase b by x, else we'll just increase a with x. Okay, that's it, right? And then we can just print the values of a and b, I mean product of a and b. Let's copy this, paste it. Okay, we need to run it, right? Sorry. Copy it, paste. We got answer as 0. Both 0 for both. Why is that? Okay, initially we need to take x as 1, right? Because we are multiplying x by 2, so x value will be not increasing at all. Let's compile it with one more time. Let's read all the values. We got 70 and 91. Perfect. It really worked perfect. Let's paste and submit. We have actually completed all the greedy algorithms questions. These 2 questions we have solved already, as we discussed. Before we need to check whether this question is solved or not. We got our 14-day streak. Okay, we got partially correct answer. Our answer is partially correct. Here the value, c value is 10 power 9, right? So let's take everything in long, and n can be, yeah, n should be long. Let's submit. That might be one of the reasons why we got a partially correct answer. And we need to solve 75 more problems to get our silver badge. Let's see how many questions I have solved till now. Yeah, it's a correct answer. The only problem is long. We need to length. Okay, anyways, let's check how many problems we have solved. Word count 41. Wow, that's a good number considering in 20 days we have solved 41. That means every day we are solving 2 questions every day. Okay, shall we go for dynamic programming? Having 2-star. Dynamic programming, we have 2 questions. Alternating array. How did we solve this? Okay, we haven't solved. Little problem with the net connection. Yeah. So the question, let's close this now. Also, let's make a alt array dot cpp. Since it's a array question, let's take our array snippet and now read the question. There is an array consisting of n non-zero integers. A subarray of A is called alternating. If any two adjacent elements in it have different signs, one of them should be negative and the other should be positive. For each x from 1 to n, compute the length of the longest alternating subarray that starts at x, that is a subarray, for the maximum possible y. The length of such a subarray is y minus x plus 1. Okay. So in the input we will be given t, and for each test case n. After n they will be giving an array for us. For each test case, output one line with n space separated integers. The length of the longest alternating subarray starting at x for each x from 1 to n. Okay. No two elements have different signs, so any alternating subarray may only consist of a single integer. Single number. Every subarray is alternating. So 4, 3, 2, 1. The only alternating subarray of length is 3. Which is this. Okay, we can take a for loop. After taking the for loop, is that the way we can solve it? Okay, we have 30 more minutes. I guess it's pretty much enough to solve this question. So after every time we need to print the x value and the constraints given are, okay, we need to take long 10 power 9 2 minus 10 power 9, so it should be long, and n is 10 power 5, so for n int is enough. So we'll take a loop. After taking the loop, what shall we do? We'll start from here. We'll take two values. Okay, we need to actually solve this question in okay, we cannot solve it in n square. We can solve it in n, order of n. So taking the for loop and comparing it with the next element, if it is negative, then we will increase the x value. So we'll take a variable x, and if current I is greater than 0 and I is less than, next element is, let's start from I1 is less than 0, that means it is negative. Then we'll increase the x value. if a present element is less than 0 and next element is okay, the previous element is greater than 0, even in that case we'll increase the x value and we will print the x value. After this we'll go for the new line. So x value initially will be 0, right? And here we'll start from here. So I will be here. So I is greater than 0 is wrong. I is less than 0 actually, and I minus 1 is greater than 0. So this condition will succeed. So we'll increase x value and we'll print it. We'll get 4, but we need to get here we are getting 1, but we need to get 4. So what is the mistake here? Or else shall we take an array instead of x? Let's take a array of x. Int array of x. The size of the array will be n minus 1 and we'll initialize all of them to 0. After that what shall we do? We'll store the array elements. We can find out the adjacent elements are positive or negative in a single if statement. That is by taking array of I into array of I minus 1. If any one of them is negative, then the value will be 0. Like let's say less than or equal to 0, then we can conclude that one of them is negative. So if one of them is negative, then we will say x of I value will just increase it. Okay, that position will be increased. And we'll also say if it is not, then we'll simply say for that value it will be equal to 1. And then we'll be not printing the whole x array. Okay, we need to also print x of I, cout x of I, and also this next cout. After printing all x values, then will we print the end line. That's it, right? I guess that's it. Okay, it's not a single number, it's an array, so let's initialize it in this way. Okay, what is the value we got? We got 0 1 1 1. Okay, 0, and we got one garbage value. Okay, actually it's not working properly. We need to initialize all this with 1, right? because 0 can't exist. The minimum size of the array will be 1, so it will be in 1. And here are we missing an element, any. Okay, here I guess everything is correct now. Let's compile it one more time. Now let's copy and let's paste this. Okay, we are only getting ones. The first test case is right, and then here we are getting some garbage value. The garbage value is because the size is n-1. Okay, that is why we got the garbage value right there. Let's compile. Sorry. Now we are running it. Let's take the sample test cases. Yeah, now we not got that, but we are doing something wrong. Okay, here the array size can't be n-1, because if n is 6, there is one number which is -5, or there can be any number that is greater than the n. That's what they said, right? So let's take a number which is 10 power 9. Okay, maximum n value will be 10 power 5, right? So let's take an array of 10 power 5 itself. So that what will be happening? Okay, we can have a 10 power 9 element also. Let's take in this. Now let's we have initialized the array with 1, and we are starting from I equal to 1 up to I is less than and I plus plus. So I guess this is it. Sorry. Still we are getting the same. I mean, only this case is being executed. X of I will be okay. Let's come in reverse actually, instead of going in from starting to end. Let's say I equal to n-2. I is greater than or equal to 0, and I minus, and here inside the condition, let's say I plus 1 into, that's why we have taken I plus. So initially n-2 means here it is n-2 and here it is n-1. So we are not accessing the nth position, so they will not get any error actually. And here x of I, which is the last second number, okay, we'll change this to x of I equal to x of I plus 1 increment. Sorry, x of I plus 1 plus 1. We are not incrementing this value. We will take the, for x of I, the value, that value will be equal to the element that is before it plus 1. since we are starting I from last. So for this we can do this. We'll take 0. Since we are taking from the start, let's make the last element as 1. So that here n minus 1 will be 1. So n minus 2 plus n minus 1 is 1. 1 plus 1 is 2. So every time n minus 2 value will be 1 because of this one value which we have given here. And if it is not, we'll be saying x is equal to 1. Here we can print till and now let's compile it. Let's copy. Yeah, now we got the right answer. Before since we are going from the starting, we are actually here we are increasing, and also we are making it to 1 every time. So that was the problem. Let's check, will I get the solution submitted? I doubt it because we are taking a value which is 10 power 5, but an array can be 10 power 9 also. Okay, this is our third. Yeah, it is submitted. We actually submitted this question. So since we have solved the 3 questions today, we'll end our session today. Since it is Wednesday, we'll be having contest today. So I'll be participating in today's contest, and after the once the contest ends, I'll also post all the solutions as a new day. So that's it for today. Thank you everyone.